This week on the show, we cover the happinesses and stresses of full-time FOSS work. We tell you how to build a FreeBSD file server. We also cover Kubernetes on FreeBSD with bhyve. NetBSD's 9 RC1 is available. OPNSense 2.1 is available as well. The HardenedBSD's idealistic future we cover a little bit, and more in this week's episode of BSD Now. BSD Now, episode 337, Kubernetes on bhyve, recorded for the 12th of February 2020, which is today. And I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Yes, a new week, a new BSD Now episode, bringing you the latest from the BSDs and around. And the headline this week is the happinesses and stresses of full-time open source operating system, free open source software work.
So this is a post on Drew DeVault's blog, and they say, in the past few days, several free software maintainers have come out to discuss the stresses of their work. Though the timing was suggestive, my article of last week on the philosophy of project governance was, at best, only tangentially related to that topic. I had been working on this article about the happiness and stresses for a while. I do have some thoughts that I'd like to share about what kinds of stresses I've dealt with as a FOSS maintainer, and how I've managed or mismanaged those. I say February will mark 1 year that I've been a self-described free software projects full-time. I was planning on writing an opportunistic retrospective article around this time, but given the current mood of the ecosystem, I think it would be better to be realistic. In this stage of my career, I now feel at once happier, busier, more fulfilled, more engaged, more stressed, and more depressed than I have at any other point in my life. They say, the good parts are numerous. I'm able to work on my life's passions, and my projects are in the best shape they've been in thanks to the attention I'm able to give them. I've also been able to do more thoughtful and careful work. With extra time, I've been able to make my software more robust and reliable than it's ever been before. The variety of projects I can invest my time into has also increased substantially, with what I once relegated to minor curiosities now receiving a similar amount of attention as my larger projects used to get when they were only for my spare time. I can work from anywhere in the world at any time, not worrying about when to take time off and when to put my head down and crank out a lot of code.
Okay, so far so good.
The frustrations, however, are numerous. I often feel like I've bit off more than I can chew. This has been the default state of affairs for me for a long time. I'm often neglecting half of my projects in order to obtain progress by leaps and bounds in just a few of them. Working on FOSS full-time has cast this model's disadvantages into great relief, as I focus on a great breadth of projects and spend more time on them. The attention and minor fame I've received as a result of my prolific effort has also had profound consequences. On the positive side, I'm somewhat embarrassed to admit that I've noticed my bug reports and feature requests on random projects, or even on my own projects, are being taken more seriously now, which is almost certainly more related to my name recognition than merit. I often receive thanks and words of admiration from my fans. Sometimes there is somewhat unwelcome, with troubled individuals writing difficult to decipher half rants laden with strange praises and bizarre questions. Other times I'm asked out of the blue to join a discussion I was unaware of, to comment on some piece of technology I've never used, or to take a stand in some argument that I'm not privy to. I don't enjoy these kinds of comments, but I'm not far removed from the ones I like. Genuine, thoughtful praise arrives in my inbox fairly often, and it makes my job a little bit more worthwhile. And I say, of course, a similar type of person exists in the opposite extreme. There are many people who hate my guts and everything I've ever worked on, and who'll go out of their way to let me and anyone else who'll listen to them know how they feel. Of course, I've earned the ire of no small number of people, and I regret many of those failed interpersonal relationships. These cases are in the minority, however. Most of the people who will tell tales of my evil are people who I've never met. There's a lot of space online that I just won't visit anymore because of those people. But he says, in either case, I can never join new communities on the same terms as anyone else does. At least one person in every new community already has some preconception of me when I arrive. Often I think about having an alias just to be able to enjoy the privilege of being anonymous again.
I can see why.
I say, I also have mixed feelings about how busy I am. Every day I wake up to 100 new emails, delete half of them, spend 3 to 4 hours working on the rest. Patches, questions, support inquiries, monitoring and reporting, it's endless. On top of that, I have dozens of other things I already need to work on. The continuous integration work distribution algorithm needs to be completely redone. I need to provision some new hardware. Oh, and the hardware that I need ran into shipping issues again, and I need to deal with that and so on. And I need to plan for the next conference, and I need to finish some work on the book I'm writing, and I need to figure out that memory issue in that other tool, and on and on. And it said, not to mention the tasks which have been on hold for longer now than they've been planned for in the first place. Alpine is still going to have hundreds of Python 2 packages by the time the Python 2 end of life hits. And the PowerPC64 Little Indian server is gathering dust in the data center. There's been bug reports against my FOSS package for several months in which it doesn't show the Patreon figures unless I reboot the process every now and then, and so on. And this is not even considering any personal goals, which I have vanishingly little time for. I get zero exercise, and though my diet is mostly reasonable, the majority of it is delivered unless I get the odd 2 hours to visit the grocery store, and so on. But it goes on, despite being swamped with all this work, it's all work that I love. I love writing code, and immeasurably more so when writing my code. Sure, there are technical debt skeletons in the closet here and there, and they're keeping me awake at night, but on the whole, I feel lucky to be able to write the software I want to write, the way I want to write it. And I've been trying to do that my entire life. Writing code for someone else has always been a huge drain on my emotional well-being. That's why I worked on my side projects in the first place, to have an outlet through which I could work on self-directed projects without making compromises for some arbitrary deadline. When I'm in the zone writing lots of code for a project I'm interested in, knowing it's going to be a meaningful impact on the users, knowing that it's going to be written under my terms, it's the most rewarding work I've ever done. And I get to do that every day. But this isn't the retrospective I wanted to write. But it's nice to drop the veneer for a few minutes and share an honest take on what it's like. This year has been nothing like what I expected it to be. It's both terrible and wonderful and very busy and very, very busy. In any case, I'm extremely grateful to be here doing it, and it's thanks to many, many supportive people, both users, contributors, co-maintainers, and friends. So thank you to all of them. Anyway, there's much more in the article, and if you want to dig into it, I recommend that.
Yeah, it's illuminating both sides.
Working as an open source maintainer is can be quite challenging because oftentimes people seem to have these expectations that you'll answer their bug report quickly enough, and that you'll just because I agree that's a good idea doesn't mean I agree to go do all that work right now.
Yeah, and just I'm not employed in that regard by you or anyone else typically, so the expectations are a bit different than, hey, this is free labor, but
yeah, but the biggest problem can end up being the expectations you put on yourself. There are lots of things I would like to be able to help people with and work on and make BSDs better and so on. It's just I don't have any time.
There's a lot of interesting things that kind of catches your attention, and you always want to work on these, or just at least keep in the loop. But it's difficult. The more you add to it, the more difficult it is to task switch between them.
Yeah, I remember a time when I first got into FreeBSD, probably peaked about 5 years ago or so, where basically I knew almost everything that was going on in the FreeBSD project. And so when I would see someone have a problem report, I would be able to mentally connect that to, oh, I know, John was working on that over there, or Mark had made a change in the VM subsystem, and that might be related to that. And, here's the bit of code you should look at, or try rolling back this change and see if your problem goes away. And nowadays, I barely have time to read the FreeBSD mail that's addressed specifically to me and not a mailing list.
Yeah, so it's difficult. It's tough. It's cool in certain ways, but it also has its I wouldn't say downsides, but it has some things that you should consider before diving very deep into the end. Although it's very rewarding. It's very nice. People are typically on the nice side and are happy that you're working on a bug fix or something, or a feature. So there's a lot of good feedback there. But as mentioned, you should definitely give mention or feedback in the show or in the email provided on the blog post. There's a good address to address thanks or some good helpful advice there. Okay, next up in the news in our section here is building a FreeBSD file server. And that is a how-to we found for you by Kevin Soltoff. And Kevin writes here that recently at his job, he was faced with a task to develop a file server explicitly suited for the requirements of the company. Needless to say, any configuration of a kind depends on what the infrastructure needs. So, drawing from his personal experience and numerous materials on the web, he came up with the combination FreeBSD plus Samba plus Active Directory as the most appropriate. And it appears to be a perfect choice for his environment, or that specific one, and harmonic addition to the existing network configuration, since FreeBSD plus Samba plus Active Directory enables admins with a broad range of possibilities for access control. So, however, as nothing is perfect, this configuration isn't the best choice for your priority, or if your priority is data protection, because it won't be able to reach the necessary levels of reliability and fault tolerance without outside improvement. But that aside, this is a very decent how-to. So he starts with what to begin with. Of course, as you probably have guessed, the creation of such a server doesn't require much, since FreeBSD isn't resource hungry at all. And for reducing its hardware footprint, he has created it in a virtual machine on ESXi 6.5 and uses a 1 terabyte Western Digital Black as data store hard drive, served by his needs perfectly. Of course, you can use a different type of storage backend, but it's just the one we're using here. They're placing that on 2 HDDs for the virtual memory OS and the storage, and he lists the parameters for the virtual machine. So 4 gig RAM, 16 gigs hard drive, 900 gigabytes hard drive for the actual storage, and a SCSI controller, virtual SCSI controller, that is a CD drive, and 1 gigabit LAN. So the 16 gigabyte disks is for the OS itself, and 900 gigs on the actual storage. Next up, you test the network resource efficiently. Let's create 2 VMs with the following parameters. So you create a similarly sized VM to move data between them. And there's a nice little diagram on the website that we have linked in our show notes, where you can see the test environment. And now you proceed with the following steps. That basically is connecting the disk drive to the ESXi host, then create a data store and create a VM in this data store, then install FreeBSD on the VM, then install and configure the necessary services and utilities, create a network resource, then introduce a server to the enterprise domain, and last is check the connection and work with the resources from more than one VM under different credentials. So he walks through creating the VM. It's not too difficult. It's a screenshot that you can just follow. Then it's time to get the installation going. We've covered this many, many times. The FreeBSD installation is just straightforward. There's a couple of screenshots for things that he selected in the installer, so just for you to follow along, and a little bit of network configuration, but I guess this is fairly straightforward. Then there's a couple of ports. After the installation, the system reboots, of course, and you log in and do some basic system configuration. And there's a couple of ports that are installed. That's personal preference in this one. It's not necessary to install them for this actual how-to. But here's, for example, Midnight Commander to install. That is probably easier for the author here to use. And now it goes into the actual file server parts. So what he does is you want to remote access to the server via SSH. So you set that up by editing SSH config and changing the parameter permit root login value to yes. Wait, what? Why is that needed?
I guess if you're used to Linux and logging in as root, but yeah, I don't recommend that part. But then they create a separate admin account, so that's good. And then they, partition up the new 900 gig space they're going to use to store the data on, and get that set up. And then they set up Heimdall and get Kerberos configured.
Yeah, for people who have not done that there, it's probably interesting for them. Then Samba is installed.
Yeah, they compile Samba with a set of different options, get that set up and installed, enable the services, set up the config file, and make sure they test the config file, and then they get it running. And you can see now they have all the Samba stuff running.
Yep, joining the company domain, Active Directory. Yeah, this is not too bad. Pretty straightforward.
Yeah, making sure that they can access the users and groups and so on in the domain. And then they can actually access that file share from their Windows servers, and it's all good to go.
Yeah, so this is a virtual setup, but it could be done in a real setup as well with physical machines. So there's all the things in the how-to that you need and adapt it to your needs.
So this is great. And having it on the official VMware blog is actually even better.
Yeah, gives the BSDs a bit of visibility, and you can just do the same things that you can use on other operating systems. All right, next up is the report from Alan directly from the first Hamilton BSD Users Group meeting.
So yesterday, or last night, I guess, we had the first meeting of the BSD user group that John and I have been trying to start. So we had basically talked about it on Twitter a couple of times, and then, after thinking about it for a while, and we decided the best thing to do is just pick a date and pick a place and have the first one and then go from there. So in early January, we decided that, we'll have it in the first Tuesday in February, or second Tuesday in February. And so that was yesterday. And so after much tweeting and announcing on the podcast a couple times, we had the thing, and we had 11 people, including myself. So that was actually more turnout than we were expecting for the first meeting. So that worked out very well. We had lots of great discussions and just getting to know people, and glad to find other people in the area who are also into BSD. It was quite interesting to see there were some people that have been into BSD longer than me, and some people who watched the podcast but have not actually had much experience with BSD yet. Yeah. I'm pretty sure that the Windows admin who sat across from me is going to be adding some FreeBSD to their network awfully soon. So that's great. I wanted to give a special shout out to the 3 Illumos users who drove in from Buffalo in the US and came up to our meetup. They were like, it was so close, we just had to. And I was like, well, that's great. And it was interesting to discover some of the connections with them. Like one of them was one of the people in Illumos who's been testing my bhyve patch for trim support, so that if you have a bhyve that's running on top of like a zvol, when we expose trim as a feature for the VirtIO device, so that when you delete stuff inside the VM, it can actually free the space on the host, which is super useful.
Oh, yes. So that's the connection. You see now the face behind that.
Yeah, one of the people that was actually trying out the prototype I made to see how it worked and so on.
Wow, cool.
Also, one of the other attendees, I'm pretty sure it was the other Andrew, but I'm not 100% sure, has registered back in 2016 a domain for the Hamilton BSD user group because they wanted to have one and just never got around to doing that. And so we're probably just going to use that. And so we're in the process of setting up, getting the website sorted out and deciding how we're going to do that. We picked the date for the next meeting, which will again be the second Tuesday of the month. So that makes it March 10th. We've not decided where yet. We liked the location we had. We will likely just do that again. But I'm also looking into getting space like at the local college or at a local innovation hub so that we would have more, well, A, it'll be quieter because it's not a restaurant, and maybe have access to a projector and so on. Although access to food and beverages is also very useful. So I'm not sure what we're going to do yet. At some point in the future, I imagine we would get to the point where we're actually having topics and short presentations and so on, in which case the projector is probably more useful. But for now, I'm kind of liking the Portland BSD pizza meetup concept of just getting a bunch of people together and getting to talk about interesting stuff for a while. But having some topics would be good too. So I don't know exactly what we're going to do yet, but we will get something sorted out and let everybody know ahead of the next meeting.
Yeah, it's great.
And hopefully we'll have a website and also an easier way to gauge how many people are coming. I didn't have anything set up for that, so I was fearing there would be only 6 people, but there were 11, so it was great. It worked out very nice. I was very happy with that.
Yeah, it's great for a first time BSD user group.
So if you want to do your own, it turns out all you need to do is pick a date and a time and a place. And it can just be a restaurant. And then you tell people about it and people come.
Especially us a couple weeks before so that we can announce it.
Yes. If you can get us notice as soon as possible, because oftentimes there's like a 2-week delay between when we record and when people might see it. And then people also sometimes don't watch the episode the day they come out. But yes, if you can get it to us as soon as possible, we can mention it in the show. And that will, I think that's where most of the people that found out about our meetup got it from. I think 1 or 2 of the people might have found it on Twitter rather than from the podcast. And Andrew and Donnie found out about it because I dragged them to the meetup by the ear.
You have to come with me now.
Well, Andrew gave me a ride to the meetup, but I got my friend Donnie to come out too. And I hadn't seen him in ages, so it was great to get to talk to him. But yeah, I recommend other people try this. And if you missed our meetup, like Ed did, you can catch the next one.
Yeah, it's always good to see people again and continue your conversations, and also for new people to join that.
Well, yes. I think the best part for me, it was, other than the 2 people I mentioned and my kind of co-host, all the other people I met were people I had never met before.
Did people did you put up a sign or something? How did people find you? Did you wear the BSD shirts or?
So when we got to the restaurant, we gave them one of our signs to put at the reception thing, like where you get seated, and that helped. But the restaurant wasn't that busy that day, and so yes, we were just the big group in the back.
Yeah, because otherwise it's like people walk around. Are you with the group of BSD? Are you with that other meetup? And they're like, no, we don't know about it.
But yes, so originally we just had a reservation for 10 people under Alan. But once we got there, John gave them one of the posters he had printed up and said, people looking for this, we're over here. And so, when you came into the front of the restaurant and they were like, do you have a reservation or whatever? And they're like, I'm looking for that. And they're like, oh, okay, it's just in the back. And it worked out well.
Okay, yeah, that helps. Bring people together that should be belong together.
Because yes, what I really needed was what they did, I think, in Paris, when we had to move the whole group from the venue to the dinner event. And they had like the people with the pitchforks they could hold up so that you could see them. You could follow the right people down the street.
Yeah.
That was very useful. But we also, we had Gruff the goat there as well, which helped.
Yes, Gruff is here at the moment in my place, but yeah, I will bring it to AsiaBSDCon. Yeah, so great that it worked out well, and hopefully it's the start of an established group.
Hopefully.
Time for the news roundup this week. We have an exciting topic for many people, because it's one of the buzzwords these days. Kubernetes on FreeBSD bhyve. I mean, bhyve is the buzzword, not Kubernetes.
So this is from the people that make CBSD, which is one of the bhyve/jail management tools. So it says, recently at my new job, my colleague and I noted a non-standard success story. In our company, we completely got rid of Docker, more than 200 containers. Although this trend has been going on for quite a few years, the de-Dockerization process has brought a lot of joy and relief to us, although only temporary.
Hear, hear.
So I'm not going to talk about the pros and cons of Docker. I will only remind you of the well-known truths that nothing is perfect. And as always, the tool or implementation of the solution that is most suitable to you is the one that's going to work best for you. In addition, in the field of IT, there's no single right way to do it. There are always options, so our area is fascinating. At some point inside our company, it came to be understood that Docker was being used incorrectly and was causing more problems than it was solving. To fix this, the IT department received the task of transferring all business processes to be microservices architecture. For this, developers must take into account the specific and characteristics of the container approach. These questions are beyond the scope of this article, but I can only say that the new concept and steps taken imply for us the use of containers on an even larger scale, when our applications are eventually ready for it. So there are quite a few solutions for container orchestration, but the most popular one and most famous and highly advertised is Kubernetes. Since I plan to conduct many experiments with installing and configuring these K8s, as they're called, I need a laboratory with which I can quickly and easily deploy a cluster in any quantities that I need. In my work and everyday life, I use two OSs very much, Linux and FreeBSD. Kubernetes and Dockers are very Linux-centric projects. At a first glance, you should not expect any useful participation or help from FreeBSD. As a FreeBSD user, you can't expect help from the Kubernetes project. But as the saying goes, an elephant can be made out of a fly, but it will no longer fly. That's not a saying I've heard before, but okay. However, two tempting things come to mind, and that is the very good integration with FreeBSD and ZFS, and being able to use the snapshot mechanism, copy on write, reliability, and so on. And the second is the bhyve hypervisor, because we still need the Docker and K8 loader in the form of the Linux kernel. Thus, we need to connect a certain amount of actions in various ways and setting up and pre-configuring virtual machines. This is typical of both Linux-based servers and FreeBSD. What exactly will work under the hood and run the virtual machines isn't really that important, so we'll let FreeBSD do it. So in my free time, I'm a member of the CBSD project, which provides end users with a more user-friendly interface for managing containers and virtual machines on FreeBSD. Another part of our users know that CBSD is a framework that, thanks to having an API, integrates very easily into any of your own scripts for automatically managing that virtual infrastructure. Thus, our task to make some kind of bridge between Kubernetes and deploying virtual machines. So this work took about 4 hours, and it turned into working K8 CBSD module, which is publicly available and will be included in the next version of CBSD.
Ah, great. So people can try it out.
There's also a video. It's not in English, but there are subtitles. So their goal here was to create a small local laboratory where they could stand up lots of different K8s and mess around. So they took a FreeBSD machine with a 3 terabyte hard drive and 256 gigs of RAM. So they have a nice server. So in other words, we have no shortage of resources. So we used the Ubuntu 18 cloud image and generated a Kubernetes cloud image, which differs from a normal Ubuntu image only in that it's connecting to a Kubernetes repository. And, so when you install apt install kubeadmin, you get all the Kubernetes tools. So they show, creating a new VM in CBSD based on Linux, and we're going to use the Kubernetes 18 image and set up some of the settings. And then they run some commands and stand up 6 different Kubernetes machines and get those all going. Or actually, they end up setting up 10 different virtual machines, and then being able to run Kubernetes commands across all of them.
Yeah, looks like pretty straightforward.
So this is the configuration stage for the master workers. Took at most 3 minutes. And it only took about 42 seconds for the VMs to boot up and join. And you can see all of the different machines ready to take work. So it says, so the cluster is ready to go. To test, you can apply the sample from the official K documentation and run your first container in this new cluster. And then in the end, you can delete the cluster and create another one. So it says, in the context of a dynamically developing IT industry, it is extremely important to automate all possible operations and get the results as soon as possible. Both to value your own time, but also to save your nerves. The use of these limited and most valuable resources to accomplish your own tasks rather than just the work that could be automated. So this article demonstrates the collaboration of a number of technologies: FreeBSD, Linux, ZFS, Cloud Init, bhyve, CBSD, and Kubernetes to raise an easy-to-use Kubernetes cluster very quickly. Obviously, the longest step, configuration and setup, can only be optimized here, since the steps perform various actions that work with remote resources, like getting a YAML config file and so on. Also, it seems like an interesting idea to be able to combine several physical servers running FreeBSD and CBSD and cross-connect them with a VXLAN and create a single layer 2 segment for all your containers, and then using Ceph or NFS or something to be able to have storage kind of bridge across there. With proper refinement, we can get a FreeBSD and ZFS-based host with fault tolerance and a scalable Kubernetes cluster in the form of a black box that does not mean closed here. It just means you don't have to worry about what's inside. As a result of a framework that does not require an IT specialist to immerse themselves in FreeBSD, bhyve, and CBSD technology, we end up with a universal API for controlling and managing your K8 cluster in the final product.
Cool. So people should check it out, provide some feedback, and get their Kubernetes running with CBSD. All right. Then we have news from the NetBSD project on their blog, of course. NetBSD 9 release candidate 1 is available. So that's news from December, but still relevant enough. So here is that they started the release process 4 months ago from the time of their blog post with a lot of improvements that went into the branch. More than 500 pull-ups were processed. Not the pull-ups you would do it's source code, right?
I think that might be the NetBSD term for like a MFC.
Yeah, that's their parlance. So this includes USB Net, which is a common framework for USB Ethernet drivers, AArch64 stability, enhancements, and lots of new hardware support, installer, sysinstall fixes, and changes to the NVMe hardware virtualization interface. And they hope that this will be the best NetBSD release ever. Okay. Only to be topped by NetBSD 10 next year, but for now, this is what you get. They have a few highlights listed here in the new release. As mentioned, the AArch64, 64-bit ARM v8a machines supported, including ARM server-ready compliant machines, SBBR plus SBSA. Then they have enhanced hardware support for ARM v7a, updated GPU drivers for Intel Kaby Lake, and enhanced virtualization support, as well as support for hardware-accelerated virtualization, the NVMe, as well as support for performance monitoring counters. Then there is kernel ASLR support given, as well as several kernel sanitizers available, Kleek, Ksan, and CubeSan. support for userland sanitizers as well. So this is one in the kernel, one in the userland. You can also audit the network stack. Many improvements in NetBSD's PF implementation, as well as updates to ZFS, reworked error handling and native command queuing support in the SATA subsystem, and the common framework for USB Ethernet drivers, which is USB-Net. You can get the binaries for NetBSD 9.1. Remember, this is just the RC1. It's not the final piece yet.
Well, this was a while ago, so the final one might actually be closer now.
Might be. Could be, yeah. We'll see. So while it's still there, try it out, give some feedback, and report problems you might encounter before the final piece is out. Or if that's already happening, then it's the next minor version that's getting those updates.
With some quick checking, it looks like release candidate 2 came out February 2nd.
Okay, so we're a bit off the beaten track here, but...
Well, we're not so far behind that they've done the release and we're still talking about the release candidates, so...
Yeah, so that's one for another show, and then we'll have a little release announcement for the next major version of NetBSD. Cool, so good luck for them.
But yeah, looking at the ZFS bits, it looks like ZFS is now usable for daily use, although they don't support booting or having your root file system on ZFS yet.
Okay, but at least more, like, if you run it as a non-boot pool, then you have a bit more functionality or more up-to-date code here. Yeah,
well, it was all very beta before, so they're actually caught up to a point where it's usable now.
Very good, considering all the architectures NetBSD runs on. This is a welcome change.
Well, I don't think ZFS runs on all of those, but probably many of them.
Not on, yeah, many more than we would normally run. Okay, that's good. Here's a release for you. The OPNSense 20.1 codename Keen Kingfisher has been released.
Yeah, so they say, hello, for over 5 years now, OPNSense has been driving innovation through modularizing and hardening the open source firewall with simple and reliable firmware upgrades and multi-language support, having a hardened BSD flavor, fast adoption of upstream software updates, as well as a clear and stable 2-clause BSD license. Release 20.1, which is named for the date, January of 2020, nicknamed Keen Kingfisher, is a subtle improvement on a sustainable firewall experience. This release adds support for VXLANs and additional loopback devices, IPsec public key authentication with elliptic curve TLS certificates, and third-party software updated to latest versions, and a logging front end rewritten as MVC with a nice seamless API. For the far side, the documentation increased in quality as well as quantity, and now presents itself with a more familiar menu layout. So they have the links to download it. The biggest improvements they note over the 19.7 release is improved performance of the captive portal, the IPsec public key, and elliptic curve TLS stuff we mentioned. They now have a CARP service demotion hook so that you can configure actions to happen when the router becomes not the main router. VXLANs and more loopback devices, like we said. Extended firmware health audit checks, I guess, to make sure that the firmware you're getting is legitimate and not compromised. They support direction and the non-quick mode on the interface rules. So you can say, this rule applies to traffic going in or out, and you don't have to have the quick rule, which changes the way PF processes the packet. We mentioned the logging updates, improved documentation, and the default version of Python is now 3.7, and they've updated to LibreSSL 3.0 and OpenSSL 1.1.1. Plus, improvements to a bunch of the plugins, updated the ports like the Mozilla certificate root and curl and so on. Known issues currently is that the update to a newer version of HardenedBSD has been postponed to the next major release. So there won't be newer HardenedBSD version images at this time. The MPD5 plugin for doing layer 2 tunneling and so on have been deprecated and will no longer receive updates. And to prevent stale config files from remote syslog, we advise you to set up new targets first and disable the old ones once that's done. And they have decided not to deprecate i386 hardware support at this time. So I think originally that was on their roadmap, but they've delayed it for now. So if you are still using a 32-bit only machine as your router, you can still use the newest version of OPNSense.
So yeah, seems like a decent release and well worth of an upgrade for your router. Oh yeah, speaking of HardenedBSD, we have also news from that project. We have the idealistic future for HardenedBSD, which is a blog post by Sean Webb, and he mentions that in the last status report we stood up their own Git server. Since then, we've migrated our entire infrastructure to point to our self-hosted Git as the source of truth repo. Over the last month, we purchased and deployed the new 13current/AMD package building server and published their first 13current production package build using that server. Then they rebuilt the old package building server to act as the 12 stable AMD 64 package building server. And then, this post basically signifies the very important milestones. They have now fully recovered from the last year's death of their infrastructure. The 12 stable AMD 64 repo, previously out of date by many months, is now fully up to date. And they have 4 build servers now in total, with nightly builds for 13, 1 for 12 stable, then 2 for package building server 13 current, and for 12 stable. Then, from there, we have 2 major improvements to make. First, deploy Kerberos plus LDAP across our infrastructure. Not only do we have those 4 servers, but we have others along with a number of jails. Unifying authentication would drastically simplify management. And the second is set up various Tor Onion Service version 3 endpoints for the various parts of the infrastructure and distribute those Onion Service host names to the various stakeholders. HardenedBSD is in a very unique position to provide innovative solutions to at-risk and underprivileged populations. As such, we're making human rights endeavors as a defining area of focus. Our infrastructure will integrate various privacy and anonymity enhancements and the technologies and techniques to protect their lives. Our operating system's security posture will increase, especially with our focus on exploit mitigations. Navigating the intersection between human rights and information security directly impacts lives. HardenedBSD's 2020 mission and focus is to deliver an entire hardened ecosystem that is unfriendly towards those who would oppress or censor their people. This includes a subtle shift in priorities to match this new mission and focus. While we implement exploit mitigations and further harden the ecosystem, we will seek out opportunities to contribute a tangible and unique impact on human rights issues. Providing Tor Onion services to our core infrastructure is the first step in likely many to come towards securely helping those in need. And they close with, we are grateful for the opportunity to serve. Let us welcome 2020 with a rebuilt infrastructure and a renewed purpose. Yeah, it's great that they got their servers back on and are ready for shipping fresh packages now. All right, time for the Beastie Bits this week. We start off with Warner Losh's FOSDEM talk. That's not too far from when it was held.
Well, this one's actually, since he was a speaker on the main track, they do an interview, text-based, with them as well. So this is actually the interview he did ahead of his talk. But yes, you can watch the video of the talk as well. Warner did a talk, The Hidden Early History of Unix, which I've only had time to watch about the first 10 minutes, but it's very good. So they asked a couple of questions, and I'll just read a couple of excerpts here because there's some good stuff in here. Because I don't know that, I think we've interviewed Warner once on this show.
Did we?
If not, that's an oversight. It might have been me and Chris that did that, because it was that long ago.
I was fascinated with, I knew how much Warner did and what he knew, but reading it was more like, wow, I didn't know he did that much, right? Even more than I initially thought.
Mm-hmm. So if you want to read the first question, then I'll do the answer.
Sure. Could you briefly introduce yourself?
My name is Warner Losh, and I'm a problem solver. He says, I've always enjoyed a challenging problem. I've worked on high precision time and frequency systems that measure the atomic clocks that went into creating the universal coordinated time. I've worked on PCIe solid state memory storage devices that predated NVMe. I've worked on the X11 UI toolkit and GUI builder designed to bridge the OpenLook motif rift back during the Unix wars. Throughout this long career, I've also worked extensively on open source software. I made my first open source contribution to the Net News Reader, which was just called RN, back in 1985. My first exposure to Unix was running 4.2 BSD on a VAX, and so I'm guessing that was at school or some kind of institution because nobody had a VAX 11750 at their house. And more recently, I've been heavily involved in FreeBSD since joining it in the early 90s. I've served on the FreeBSD core team on and off for a number of years, and these days I work at Netflix optimizing storage performance on their OpenConnect appliance video servers. He says, I also fix dinosaurs, by which he means he does a lot of work on basically classic computers. I think he runs some kind of like unofficial floppy recovery service for like not your MS-DOS formatted floppies, but like, you know, the kinds of floppies that are rare. Mm-hmm. He has enough of the old dinosaur hardware to maybe actually be able to recover the data off your, 320 kilobyte floppies or whatever.
Oh, okay. Yeah, that's rare in case you still need some data of those and it can still be read. So then they talk or ask what your talk is all about exactly. Why this topic?
So he goes into, my talk is about the hidden gems in the early history of Unix. While many talks have been given about the history of Unix, they tend to gloss over the first 10 years or so. That was quite an exciting time in Unix's development, and many interesting and exciting firsts for Unix occurred during that period, and not later as many people believe. I became interested in this stuff a few years ago when a copy of Venix, VENIX, for an old DEC Rainbow that he has resurfaced. It was the only Unix available for the Rainbow back, in the 80s. In the 80s, when I first bought my Rainbow, Venix was too expensive. However, once I got my first job and was able to afford to buy it, it wasn't available anymore. The DEC Rainbow community thought Venix to be long lost to the sands of history. A couple of years ago, installation disks for it were found, and I helped recover the data from them and recreate copies of the disks so that other people could actually install it on their old dinosaur DEC Rainbows and give it a try. This led to closer exploration of what made Venix 2.0 release actually work. It was an Unix 7th edition port with some BSD and some System 3 editions mixed in. I thought it would be cool if I could recreate Venix binaries from now released source code. This led me to write an emulator for Venix binaries so I could run the Venix compiler on something other than my super slow and incredibly fragile DEC Rainbow. That led to research into what source code was available, and I discovered an active community at TUHS, the Unix Heritage Society, TUHS. Through them, I discovered different interesting papers and sometimes even source code about cool features predating by years or even decades my notion of when Unix got that cool feature. During this time, the PDB-7 Unix sources were discovered from paper listings by volunteers at TUHS, and then they transcribed those into the computer and enhancing the emulators so they could actually run them once again. Since this started, I've spent hundreds of hours reading, studying, and searching through the history of Unix. Along the way, I found a lot of cool ideas, technologies, and artifacts that I hope to share in my talk. It actually brings back the conversation from the Unix group meetup last night, where John had never heard of Plan 9 before. And we were trying to explain Plan 9 was what the Unix people did when they took the concept of Unix maybe a little too far. But at the same time, a lot of those ideas from Plan 9 seem to get reinvented over and over again, or, every so many years, like maybe now we can handle this concept of, they had like content addressable file system and the Plan 9 replacement for NFS, which looks like might actually end up in bhyve as a way to share files between the guest and the host, and all kinds of interesting ideas that came from Plan 9. But it's really interesting to see a lot of the the stuff we've come up with, like the idea of virtual machines becoming popular and containers and even just the concept of the cloud, is really just reinventing, Unix time sharing and there's one big computer and we all share it, rather than the concept of everybody has their own computer that's separate.
Yeah, they were ahead of their times in certain ways.
Yeah, in Unix, we seem to keep coming in these circles and coming back to the old ideas, and now we just happen to have enough hardware or enough of the right concepts to re-implement them.
So we recommend you read the rest of this interview, and of course watching the talk from Warner. That's very insightful if you're into the Unix history. Next we have the relational pipes version 0.15.
Yeah, so it says, we are pleased to announce the new development version of relational pipes. This release brings two big new features, streamlets and parallel processing, plus lots of other minor improvements, including variable length integers can now be signed, so you can have negative numbers, and are included as SLEB 128. But if we jump to the FAQ, it might explain what's going on here.
What relational pipes are, yeah. Here's a section. Relational pipes are an open data format designed for streaming structured data between two processes. Simultaneously with the format specification, we're also developing a reference implementation, like libraries and tools, as a free software. Although we believe in the specification first or contract first approach, we always look and check whether the theoretic concepts are feasible and whether they can be reasonably and reliably implemented. So before publishing a new specification or its version, we will verify by creating a reference implementation, at least in one programming language. Yeah, so it's a philosophical continuation of the classical Unix pipes and the relational model.
Yeah, so with the parallel processing stuff, they say there are two kinds of parallelism. You can parallelize over the attributes or over the records. Because streamlets are basically forked processes, they are quite naturally parallelized over the attributes. You can compute the SHA-1 hash of one streamlet and the SHA-256 hash in another streamlet, and we can utilize two different CPU cores that way. Or we can ask one streamlet to compute both of those hashes, and we'll utilize only one CPU core. Or the relpipe in file system tool, simply feed all streamlet instances with the current file name, or streamlets work in parallel, and then the tool collects the results of all the streamlets at the end. But it would not be enough. Today, we usually have more CPU cores than we have attributes that we want of the file, like hashes or whatever. So we need to process multiple records in parallel. The first design proposal, which was not implemented, was that the tool will simply distribute the file names to standard ins of particular streamlet processes in a round-robin fashion, and processes will write the output to a common standard out, but with a lock to synchronize to keep the records atomic, so you don't get line mixing and so on. This was really simple and somehow helpful, but it was better than nothing. But the design was had a significant flaw. The tool is not aware of how busy a particular streamlet process is, and will feed them with tasks like file names equally. So it will work satisfactorily until, in case that all the tasks have similar difficulties. Whereas, that's how ZFS used to distribute writes across VDEVs. Whereas now what it does is it gives each VDEV a little bit of work, and then whoever's finished first gets the next bit of work. So that, if one worker is able to do more work, you might as well give it more work rather than giving everybody an equal amount of work. So it says, so it will work satisfactorily only in cases where everything is about equal difficulty. In this, unfortunately, is not the usual case, because computing a hash of a big file takes much more time than computing the hash of a small file. Thus, some streamlet processes will be overloaded while others will be idle, and the whole group will end up waiting on the overloaded ones. We don't want that. So the solution was using a queue. This tool will feed the tasks, like file names, to the queue, and the streamlet processors will fetch them from the queue as soon as they are idle. So we will utilize all the CPU cores all the time. Obviously, if you have more records than you have CPU cores anyway, which is usually the case. Because our target platform are POSIX operating systems, we chose the POSIX message queue as the queue. It is nice and simple technology, and it's standard and really classic. It does not require any broker processor or any third-party libraries, so it does not bring additional dependencies. it's basically provided directly by the OS. However, there are fallbacks still possible. Like if you set --parallel 1, it will run directly in a single process without using the queue. Or, POSIX MQ have quite simple APIs, so it's possible to write an adapter and port that tool to another system that doesn't have POSIX MQ and use something else. You could add another queue to the output side and use it to serialize or for serialization of the stream so that all your stuff going out standard out is in the right order, but it's not necessary thanks to the relational pipes format design, and we'll add just some more overhead. So on the output side, we just use a POSIX semaphore to lark guard the output so that we don't mix two different outputs on the same line, and thus the tool still has no other dependencies than the standard library of the operating system. If we still have idle CPU cores or machines and need even more parallelism, Streamlets can fork their own subprocesses and use threads or some technologies like MPI or OpenMP. However, simple process or parallel processing of records is usually more than suitable and efficient to utilize for the type of hardware that most people have.
There's much more. Yeah. It's a big article, so you could definitely dive in more. And of course, there's a roadmap and other things that you could follow. So it's an interesting concept for the pipes on steroids, I guess. Next, we have a reminder for where to find NetBSD ARM images because they're over at armbsd.org/ARM.
Yeah, basically because there's so many different bits of ARM hardware, they have so many separate images, they set up a separate website for them. So, if you have, so they have generic 32 and 64-bit ARM images, but they have special images for QB-Board 2, QB-Board 4, QB-Truck, QB-Truck Plus, and NanoPi N1, or M1, sorry, NanoPi Neo, Neo Plus 2, the Neo 2, Odroid C1 and C1 Plus, Odroid 2, Odroid XU3 and XU4, Banana Pi, the Libre computer called Le Potato, the Hummingbird A31, all these Linuxinos, the Pine A64 and A64 Plus versus the Pine A64 long-term support version or the Sopine, Pine H64, Pinebook, Pinebook Pro, Rock 64, Rock Pro 64, Banana Pi, Orange Pi 2, Orange Pi 1, Orange Pi Plus 2E, and the Orange Pi 0.
Oh yeah, plenty of devices and ARM code available running with NetBSD. Then we have a mailing list post from Jeff Robertson about a new safe memory reclamation feature in UMA.
Yeah, so UMA is memory allocation caching system in the FreeBSD kernel. It allows you to basically create these buckets saying, I'm going to need to allocate a lot of this particular structure or something. Like, in ZFS, we create a bucket for 128K records because we're going to have to allocate those a lot when you're doing stuff in ZFS. And so when you free one, it goes back into that bucket and it becomes, basically gets zeroed out and ready to go, but we don't actually free it and then we have to reallocate it again. So when you use a bunch of 128K buffers and then free them and then need them again, it's much faster to have them already ready to go rather than need to allocate them again. And it helps with fragmentation and so on. So what Jeff has implemented here is what's called safe memory reclamation. It's basically a technology that allows various types of lockless synchronization by eliminating the risk of use after free. The biggest problem we have with memory in C is that after you free some memory, if you still have a pointer to that memory and you tried to use it for something, you'd then be using that memory after we freed it, which, someone else might have overwritten it by now, and then your changing to it will corrupt it for what the new person's supposed to do. So when you're running the debug version of FreeBSD, it checks for this and will crash the system if you ever try to use memory after you freed it. Because when you free it, you promise, I don't need this anymore. And so using it again is bad. Anyway, but the problem with trying to do lockless stuff on memory allocation like this is how do we make sure that everybody's done with it before we free it and so on. So, there's a number of different approaches to this. like Linux uses RCU, there's QSBR or EPIC or Parsec and so on. And so there's quite a lot of material available on the uses of these algorithms. So if you want to do more research on how this works, you can do that. Anyway, most of these algorithms suffer from holding on to freed memory for a relatively long period of time and reclaiming it when that is now cache cold, meaning that, in order to make sure that everybody's done with this memory before we give it to someone else, we wait for it to not be busy anymore. Just wait for a while before we mark it as free. The problem with that is now those memory pages are not on the CPU's cache anymore, and so it'll take more time to load them again, to mark them as allocated and be able to use them. It also creates quite a lot of resource starvation edge cases where, we freed a bunch of memory, but it hasn't timed out yet, and so it's not actually available to reallocate. So we have free memory, but we have no memory we can use, and that's not good. This is evident from the amount of code in the RCU system in Linux intended to work around these issues. These algorithms are generally best when you have a small write-free workload and you're mostly just doing reads all the time. But, the FreeBSD kernel, that's not usually the case. So for the virtual memory system, I needed something that could sustain really rapid freeze, and I've ended up with a scheme that integrates with the allocator and uses a novel epoch/version tracking mechanism. Using these two concepts together gives me a 3 times faster performance with 1/20th the memory overhead of the existing epoch implementation in his obviously contrived performance benchmark, which is best case for his new thing. I don't want to imply that if we replace the network epoch system with this UMA SMR, that suddenly the network stack would be 3 times faster. That's not how that works there. But I do think there may be benefits, especially for some of the really high turnover parts of the network stack, like PCBs, which is basically the structure that tracks like TCP connections. And so obviously those get allocated and freed all the time. Every time you close the connection, you throw away that PCB, and every time someone opens a connection, you make a new one. Well, if you're say a Netflix box with 10,000 people watching videos off of you, that's going to happen a lot. Because especially the way Netflix works, generally the client connects, downloads a bunch of minutes of video in a couple of seconds, and then disconnects and comes back later. So there's a very high turnover there.
Oh yes, for sure.
Anyway, it says currently the SMR stuff does not support sleepable sections, so there's still a lot of technical work to be done between here and being able to use it in the network stack. But there is a lot of information in the review and comments within the code. I'll be validating this on weaker memory ordering architectures, so architectures where the hardware doesn't necessarily guarantee that the memory stuff will happen in the same order as you asked it to. And it still needs a man page. I would like to spend some time finding a snappy name to avoid confusion with other algorithms, because, probably mostly because I'm a storage guy, SMR is shingled magnetic recording, not safe memory reclamation. So,
yeah, 3 of the acronyms.
Maybe just call it SafeRec. It's not quite as short as SMR, but I kind of, it's less ambiguous because obviously it's safe reclamation.
Yeah, as long as people don't write safe WRECK, that's fine.
Sure.
So thanks, Jeff, for implementing that. And people should provide feedback and testing. And then we'll hopefully see that in one of the future FreeBSD releases.
Yeah, I wish I had time to play with that a bit because, in ZFS on FreeBSD, we heavily used the UMA system for providing memory. And it'd be very interesting to see, if this actually provides a bunch of improvement there or not.
And last in this section is a reminder to the people from the greater Sweden or Stockholm area. There's the BSD user Stockholm meeting on March 3rd. You can still attend, of course. There's the meetup.com website for it. And it's happening...
Yeah, Tuesday, March 3rd. At 6 o'clock until 9:30, and they ask that you RSVP by 3 o'clock so they can order food.
Yeah, exactly. That's better preparation for the organizers. And it's been running for a while, so there's a couple of people who are who've been there before, and there are also new people. So it's definitely a good mixture.
Yes, it looks like this particular meeting has 31 people that say they're going to attend so far.
Ah, wow, cool. Even better, so you have a little bit of a crowd with BSD-minded people. All right, time for the feedback and questions section that many of you are always looking forward to. But this section will be very empty in the future if we don't get more feedback and questions. So anything that you have found or are struggling with, need a little bit of advice from us or the other people, if we don't know the answer, send all that to feedback@bsdnow.tv and it will appear in a future episode, hopefully soon enough so you can get your answers for your problems. The first who did that is, it's a ZFS question. We don't actually get who that was, but that's fine. It's about ZFS, Rosetta Stone document, ? Here goes. Hello, Alan, Benedict, and JT. I am rereading Alan and Michael W. Lucas's ZFS books to refamiliarize myself before delving into the Jails book. Even after all those years, there is so much information. The books are still like drinking from a fire hose, even after all these years. So for me, the problem in ZFS is threefold. First, I generally do a tiny subset of ZFS commands. So when I need to do something not on that list, I have to search.
One of the things I'm looking most forward to that came out of the OpenZFS hackathon last November, is the splitting up of the man pages.
Ah, that's happening.
So every ZFS subcommand and every zpool subcommand will have its own separate man page. So it'll be much easier to find the stuff you're looking for. Right now, the giant monolithic man pages, even when you're searching for the subcommand you want, it's mentioned in a couple of different sections. It makes it very hard to oftentimes I just want to know what are the flags for ZFS send or list-p and h or whatever. And it can be a bit hard to find, whereas being able to just shortcut to man ZFS-list and get just the help on list will be very helpful.
Yeah. Oh, yes, that's good. To not have one big bloated web page, not web page, man page. Good. Then commands can be so similar, for instance, ZFS list and zpool list, yet have different outputs.
Yes, so obviously the ZFS command and the zpool command are different things. So ZFS commands are for the file system, and the zpool commands are for the volume management. But yes, people often get confused by looking at the amount of space, both allocated and free, in the zpool list command. Mostly just pretend those aren't there. They mean something very different than what you're used to. Because in ZFS, the parity is dynamic. So when the parity space doesn't get used up until you write a block. So if you say you have a RAID Z2 and you write a 4K block, if you look in ZFS list, you'll see the free space went down by 4K and the use space went up by 4K. Makes sense. But in the zpool list, you will see a lot different. If it's a RAID Z2, then you're going to have written 12K, the 4K block and 2 parity blocks on 2 different disks. Plus, you have the metadata that points to that block, which might have 2 or 3 copies. And so you can end up using like 96 kilobytes of space just to write that 4K. And, it's very dynamic. If you happen to write 16K, the numbers work out completely differently. And it's confusing to think about. So ZFS list does it all in the background for you, and it knows how much overhead there's going to be and gives you numbers that make sense. And zpool list will give you implementation detail numbers, and you shouldn't worry about those. But yes, the fact that some of the commands exist in both the ZFS and zpool command can be a bit confusing. But mostly ZFS command is when you're dealing with your files, and zpool command is when you're dealing with your disks.
Third, ZFS is so darn reliable that there are many things that I don't do for years. Last week, I did my first drive replacement in years.
Yeah, every once in a while, it's like, oh, that's something I haven't had to do in ZFS in a while. Going to need to look that one up.
It's like everyone knows how to do an ls command because they're doing it every day. But, the drive replacements, luckily, don't happen very often unless you have many, many disks that are dying. And so, if you don't do things too regularly, then you have to look it up, of course. I'm compiling notes as I encounter things in ZFS, but would like to see a kind of Rosetta Stone document with as many of the more common tasks and information in a short format document. Is there any such thing out there?
A Rosetta Stone actually implies something slightly different. So if you think back to the history of the real Rosetta Stone, it was the same information written in what I think was 3 different languages, and it allowed translation from one to the other. So one of the Rosetta Stones I would have talking about recently that we would like to create in FreeBSD is, say, a package Rosetta Stone that would explain, hey, if you're coming from CentOS with Yum or Ubuntu or Debian with apt, here's how to translate, this Yum command that you normally use becomes this package command on FreeBSD. Or this apt command you were using becomes this package command on FreeBSD, to help people who already know how to do something on a different system be able to do the same thing on FreeBSD. Whereas I think what you're looking for is a bit more of a quick reference guide, which we need those too. I don't know that one of those really exists. I made a terminology sheet as part of the ZFS chapter that tried to explain what a bunch of the special words that ZFS uses are. But, I don't really have a quick reference. There's not a quick reference guide handy on just some of the common ZFS commands. Now, I've seen somebody's got a template, I think, and I've seen a bunch of really good ones for like common Git commands you need, or VI things, or just like common command line tools and what, the 10 most commonly used commands or whatever would be. And having something like that for ZFS would be really good. It's like, oh, you need to replace a disk? Here, you do it. If you want to, grow your pool, make sure you remember to do it this way and that way and so on. It'd be really great to have. So if you make that, do send it in and maybe consider getting it as part of the FreeBSD handbook. Because outside of that, the ZFS books and the FreeBSD handbook ZFS section are your best bet. If you need to remember how to replace a disk, there's a chapter in the ZFS handbook that covers that.
Yeah, so that could use a little bit of extension and love maybe. But yeah, definitely a good idea to have this, or a wiki or something that someone has started and other people continue that, as ZFS involves in the meantime as well. So yeah, thanks for that question. Next up is Pat with a question that goes like this. Hi, Alan and Benedict. I plan to set up a home server shortly, powered by FreeBSD and ZFS, of course. And I was wondering if you had any advice when it comes to hard drives. Are consumer-grade hard drives okay for 24/7 use, or are enterprise-level drives a must from your own use cases?
So for that part, mostly it depends on your stance on warranties. Some desktop drives won't get replaced under warranty if they've, ran their whole life cycle. So, when they say, oh, this desktop drive has a warranty of 3 years at 8 hours a day, well, then you can go through that in 1 year if you leave it on 24/7. It depends on the manufacturer and stuff. And generally, they'll still do a warranty on it. Although oftentimes, if you try to warranty 4 of them at once or something, they're going to be like, yeah, we don't do that. So my home NAS is all desktop drives, and they've been fine. There's the NAS drives that are kind of somewhere in between desktop and enterprise drives. But yeah, again, it mostly comes down to how you would deal with warranties and how long you're going to use the drives and so on. But no, I've been fine with desktop drives. It mostly comes out if this is your home server and it's just for home stuff, then, if you're willing to take the risk that the drives are slightly less reliable, that's fine. If you're building something for, mission critical stuff at a business, you probably want to consider spending a little bit of extra money on the slightly better drives. But in the end, they're mostly the same hard drives inside.
Yeah, and for the second part, also, do you mind sharing your opinions on whether hard drives should be left spinning versus allowing them to spin while not in use?
Yeah, so spinning down, I've found, is usually more harmful than useful. You definitely don't want the drive to be spinning down and waking up frequently.
No.
On my file server, my hard drives never spin down. But, in general, ZFS is writing a little bit of data to it every 5 seconds. So if they try to spin down, that can really mess with them. Like, oh, I've been idle for 3 seconds. Let me spin down. 2 seconds later, the drive's like, hey, wake up. We got work to do. And then they end up spinning up and down all the time. And that's uses more electricity and is wear and tear on the drive. So I've never bothered trying to spin down the drives. I'm sure the people on the FreeNAS forums have all kinds of opinions on this, but I just don't bother.
Or start with a single drive or two for redundancy. And then, you can always extend and exchange drives as long as you have enough redundancy there. So that's not a dead end.
Yeah, like in general, for people building home NASs, I like to recommend mirrors, even though, that's not as much space for the same money. It gives you more flexibility. If you buy 2, 4, 6 terabyte drives now, whatever the ones where the price point is the best, because now basically if you're getting smaller than 3 or 4 terabytes, the price per terabyte is worse than getting bigger drives. But buy the drives that are, the right ones you find on sale or whatever, and start out your NAS. If you do that with, say, 4 drives, 2 sets of 2 mirrors, you only have 2x the space, versus if you'd done a RAID Z1, you'd have 3x the space. But, when you, down the line, when you can buy bigger drives, you can decide to buy only 2 and upgrade and get some of the more space right away. Whereas if you did a RAID Z, then you have to replace all the drives in the RAID Z or add another whole group like that RAID Z in order to get more space. With mirrors, it allows you to, every year for Christmas, just buy 2 of the best priced drives and replace your 2 smallest drives with the 2 new drives. And then your NAS will just grow every Christmas. And it can be much more affordable than having to buy a large number of drives at once.
Yes, so that's an approach.
So, it hurts a bit in the short term because you have more wasted redundancy. But in the long term, it gives you that flexibility, which can be quite nice.
Yep. And there's always learning happening, even if it's not the first time that you have the perfect home NAS.
Yeah, and ZFS is trying to get better at the flexibility stuff. Like someday we'll have the RAID Z expansion thing, which will allow you to just widen your RAID Z, but that has some caveats and isn't necessarily the solution to your problem either. Because if you have a 4 or 5 wide RAID Z and you add another disk to it, well, if your original disk are 2 terabytes and your new disk is 6, well, the new disk only gets 2 terabytes of its space used. So you run into problems like that.
But yeah, hopefully we give you some pointers to get started and let us know how it went. That's always good to hear like experience reports or how this thing is going for you after a while so that other people can follow your example. Okay, and last but not least is Zigflop. I guess that's the name. And Zigflop writes, "Hey, I'm using OpenBSD and it very much sounds like OpenBSD is going to stick to Xorg. Is Wayland just a Linux thing, or are there any BSDs that support it?"
So I know there's been some work to try to get something like that going on FreeBSD. You were at FOSDEM. What was the...
Yes. So Raichu was working on that, and he got the basic compositor running, and it mentioned that running that, it shaved up a whole hour of battery time on his laptop rather than the classical Xorg. So that's an interesting thing.
Yeah, so it's not fully there yet, but Wayland on FreeBSD is starting to become a thing.
Yeah, so there's a couple things that need to be fixing. He mentioned a couple of things that if you move a window around, there might be certain areas that don't move with it or are just staying where they were before.
Just don't get redrawn properly and so on.
Yeah, but he makes progress, and he got a couple of good feedback and things from his talk at FOSDEM as well. So I guess this will be a way into a new desktop future sooner or later.
Yeah, FreeBSD's been keeping this on the radar because it seemed for a while like, the Intel graphics drivers were going to be focusing in that direction. I don't know that that's the case anymore, but it's definitely, one of the places where we don't want to get left behind. So it's good to have people working on it.
Yeah, if anyone knows about the efforts on NetBSD, I guess it mostly is package source, then let us know. Then we'll give a follow-up update, or maybe there's more information about it that we can put into the show, and then we'll be happy to do that. And yeah, it's perfectly fine at this point to stick with Xorg. That's not going to die soon, and it's still working. So that's all there is we have on that for now. But thanks for sending us that question, because people always ask, hey, what's the newest, coolest things in the desktop area? And that's another road that people could take. All right, so that's the end of our show. Thank you for listening again. If you have anything for us for future episodes to fill, then send it to feedback@bsdnow.tv, and then we'll have more content for you.